Hello, back at it again. This is Mr. Abbott's Math Videos, and now we are just continuing on with Learning Guide 3 in Pre-Calculus 12, the polynomial functions. So I'm just going to go through a little review now of factoring, all right? Because factoring is very important here in this next part coming up. So let's just review. The types of factoring. When you are factoring, you got to always remember GCF. So let's just go through an example here. So if I have, say, 3x squared plus 6x. Well, when you factor this, the GCF is 3x. So you take that out because it's common there, and it's common there, and you get x plus 2. All right, so we're always looking for GCF. Take these guys out, and then we try and do something with this. But in this case, that's it. Okay, now, if you have three terms, we call a trinomial, we just go about this. So let's say we had x squared, minus x minus 12. So just remember that when you are factoring trinomials and there's no GCF, you take the last term, the constant here, and we do what's called a t-chart. So we have 1 times 12, 2 times 6, and 3 times 4. Now this negative sign is really important because it's got a negative there. That means we're subtracting, we're subtracting, we're subtracting. So I get negative 11, negative 4, and negative 1 when I take the difference. And I'm looking for a negative 1 here, because see, negative 1. So I know it's got to be these guys. So I go bracket, 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 x and x, because x times x is x squared, a 3 and a 4, and remember it's a minus 4 plus 3, because these two have to add up to that guy. And they do, negative 1. All right, difference of squares. Difference of squares is, remember, a difference is a subtraction sign, and a square is like an x squared and say 25. So these are the squares, and this is the difference. So difference of squares are two terms. Now, these are pretty straightforward because we know x times x gets us this, 5 times 5 gets us this, and it's plus and minus always. That easy. Okay, triple play or decomposition, I'll show both. So if we have something like this. Now, triple play is this. We do what's called the setup. That's the first place. You take this guy, 3x, 3x all over 3. Then we take the two outsides and multiply. So we get our negative 15. And we do the same t-chart we did over here. So we got 1 and 15 and 3 and 5. And we're trying to get a negative 2. Well, those get me the negative 2. So a 3 and a 5. And I want a negative 2, so a negative positive, because those two get me that negative 2. Now the last play is we got to get rid of this guy. Does it go into that? Yes, so we know it's going to go into both. So 3 divided by 3 is just x. 3 divided by 3 is just 1. And then this one drops down. The answer. Okay. Now if we did it through decomposition, which is another great way of doing it. So decomposition. We would set it up like this. Okay, so we have 3x squared, and then we take the other one, minus 5. Now, we do the same t-chart right here. All right, and it's going to be these same terms, 3 and 5, so 3 and 5. But just remember that these have x's now. And the signs are going to be plus and minus, because remember the middle term right here. The middle term is minus 2x. These two right here have to get us that guy. And I know it does. Okay, so those two add up to that. So now I know that we have to group. That decomposition is grouping. It's really, decomposition is another thing is we can say it's factor by grouping. Okay, so let's put a bracket here, a bracket there, a bracket there, and a bracket there. So we'll group those up. Now sometimes these have to switch, but in this case, I think we're pretty good. So let's just leave it. Okay, let's look for a GCF here. So we have a 3 and an x, so that's x plus 1, because that times that, that times that. Here we have 2 negative 5, so negative 5, and here we have x plus 1. Now you do the happy dance, because if you get these brackets to be the same, you've done something right. It's going good. So we drop that down, and these two I call the garbage, comes into the next bracket, and there's the answer. All right. Now combination, this combination is just 2 steps. So let's say a 2x squared plus 4x, and let's say it was minus 16. Okay, so let's look at what's common here and here and here. So this first step, this GCF, is really important. So we take a 2 out, so that's 2x minus 8. Now you look at this. Before you say final answer and move on, you ask yourself, can this guy factor? And the answer is yes. Because what multiplies to 8 and adds to 2? Well, it's 2 times 4. So it's x and x, plus and minus, and there is our answer. So let's just go through these quickly, and I'll give you some time to practice, and I'll just write the answers up. So hopefully you have them. So here, hopefully you have B and B, 7 and 1 plus and plus. Number 2, N and N, 1 and 10. And because it's a minus there, they're both minuses, because a negative and a negative is a positive. I'll watch out for that. Here we have 9 and 10, because that gets me the 1, so plus and minus. I want a positive 1 there. N and N, and we have a 2 and a 6, because that gets me the 12. And if I put plus and minus, that gets me the positive 4. And 9 and 1 and minus. Again, a minus and a minus is that positive. And the last one here, we have a B and a B, and 8 times 8, 64 plus and plus. You can see it like that, or if you want, you can write that. So it doesn't matter which way. Most often you're going to see this in textbooks and work, but you can write it like that. Now this next section is going to be triple play or decomposition. So it doesn't matter which way you want. So let's do it through decomposition, because it's probably a way we are going to use later on in math. So we have 3p, and we have minus 5. You take those, you get minus 15. And I have a 3 and a 5. So a 3 and a 5. And it's a minus P, and this is a P, right? Don't forget that, and a plus, and a bracket, so 3P comes out, so it's P plus 1, and minus 5P plus 1, so P plus 1, 3P minus 5. So here we have 2n squared and minus 9 times out to get minus 18. And we're looking for 3 and 6 because that gets me that 3. So a 3n and a 6n and a positive and a negative. Okay, so if you take a quick look at this, things that are common, not so much. But if I switch these, it would probably make more sense because I know 2 goes into 6. So you can switch. You're just trying to get a common bracket. So let's see if I did it. Okay, so 2n in plus 3 minus 3n plus 3. I did it correctly. By doing that switch, I got like brackets. All right, and here we have 3n squared plus 4 rainbow, which is 12. And then we have 6n and 2n. And they have to be both negatives, because remember, these two have to add up to that. So now I bracket. So 3n, so that's n minus 2, minus 2, n minus 2, and so I have n minus 2 is like, and then 3n minus 2. And the last one here, we have 5n squared, 12, and then that times that is 60, and then we have 4 and 15 multiply to 60, and they add to 19. Now when I'm looking at this, I'll probably put 15 with this guy and 4 with this guy. Just to me, I think it'll make better sense when we factor out commons. And 4 comes out, and it's n plus 3, and so 3n, 5n plus 4. All right, a few different ones here. We got some difference of squares going on here because 2 terms, different sign. So it's 4n, because 4 times 4 is 16, plus 3 minus 3. Here, same thing, 2 terms, a minus sign, so it's 2m, 5 and 5, plus and minus. Here, I call it the goalposts. They're both perfects because 4 times 4 is 16 and 5 times 5. And 4 times 5 is 20, and 20 doubled is that. So we know it's going to be, we call the special cases. So it's 4b, 5, 5. And it's got to be minus and minus, because we're trying to go a minus there. So you can rewrite this as that guy. And these are all the same, difference of squares. That's the same. These guys are the same as up here, so I'll let you guys play with those. And these ones are GCFs, because there's a 2 common in all that one, so 2 comes out. Now, can we factor that? And the answer is yes, because we have 6 times 9 is 54.